Hi, Billy Mays here with The Mole. Today we'll be talking about percent composition. So let's take a look. Think about that word percent composition. Well, we know composition means what it's composed of. Let's start this shit again. Alright. Hi, Billy Mays here with The Mole. Today we're having a look at percent composition. Let's take a look. So let's think about those words, percent composition. We know composition means what something is composed of or made of. Percent relates to a portion of a whole times 100, of course. Now here we see the definition is the percentage by mass of each element in a compound. Let's look at an example. What is the percentage of sodium in the compound sodium chloride? Well, some people would say it has sodium and it has chlorine, so it must be 50% sodium because it's one of the two elements involved. But when we take a closer look at molar mass, we can see that they have two entirely different masses that they contribute. So the entire compound's total mass, half of that is not sodium. But let's look further. We see the formula for percent composition as the mass of element divided by the total mass times 100. When we apply this, we notice we have the individual elements' masses, and we need to find their total mass. That's 58.44 grams. Well, we take percent composition by doing the part over whole times 100. In this case, we want the mass of the individual element, which is sodium. To find the percent sodium, we place its mass of 22.99 in the numerator. We divide it by the total mass of 58.44 grams. And we see we get, when we multiply that by 100, a percent composition of 39.34%. So sodium does not make up 50% of the compound sodium chloride. Because it has less mass to contribute, it makes up a smaller portion of the whole. So let's look at the steps for finding percent composition using this example of copper sulfide. First, we want to find the mass of each element. Copper, we see, is 63.55 and sulfur is 32.07. Remember to round it to the hundreds place. Now because we have two coppers, we multiply its mass times 2 and get 127.10. So you want to find the mass of each element first before you go on to step 2 and find the total mass of the entire compound. To do that, you just add up the 127.10 plus the 32.07 given by the two coppers and the one sulfur, and you get 159.17 grams per mole. Next, you can find the percent composition of each element. Looking for the percent of copper, then you take the mass of copper and divide it by the total mass. Don't forget to multiply by 100, and you get a percent of 79.85% copper in this compound. Now to find the percentage of sulfur, take the individual mass of sulfur of 32.07 grams and divide it by the total mass of 159.17. Don't forget, times 100 and you get yourself a percentage of 20.15% sulfur. You can see the copper made up a much bigger portion of the compound, therefore has a much greater percentage. The sulfur was only a small portion and a small percentage. Want to check your work? Well, add up the two percentages and they should be very close, if not exactly 100%, and they are. So we're good to go on. So let's do an example. Let's find the percent composition of a sample that has 28 grams of iron and 8 grams of oxygen. Well, you can see we have mass contributions already. So we could use those and just find the total mass by adding 28 plus 8 and getting 36 grams. What percent is iron? Well, 28 grams divided by 36 grams times 100, and you get 77.78% iron in this compound. Find oxygen by doing 8 grams. It's part over the whole of 36 grams, and multiply that by 100 for a percentage of 22.22% oxygen. Also, you can see, checking that out, it does add up to 100%, so we're good to go. Example 2. If you have a 38 gram sample of copper 2 sulfide, copper 1 sulfide, how many grams of copper are in there? For this one, we got to use the numbers we got earlier. We know that there was 79.85% copper from the problem we just did a little while ago. Well, if we want to know the portion of copper in 38 grams, then we take copper's percentage and multiply it by 38 grams. Don't forget to move the decimal over 2 places before plugging a percentage into the calculator. And you multiply those two numbers out, and you see that the mass, or the contributed by the copper, is 30.3 grams. So out of 38 grams of copper 2 sulfide, copper 1 sulfide, let's do this slide again. Alright, let's take a look at example 2 of percent composition. How many grams of copper are in a 38 gram sample of copper sulfide? Well, we learned earlier in a problem we did that copper makes up 79.85% of copper sulfide. Well, if we know that there are 38 grams total, we can multiply that by the percent composition of copper to find the number of grams of copper. Remember, before you use that percentage of 79.85, move that decimal place over 2 spaces. 38 times 0.7985, and we know that there are 30.3 grams of copper in our 38 gram sample of copper sulfide. Example number 3. Find the percent composition of water in calcium chloride dihydrate. Now this is your classic percent water in a hydrate problem. Pay attention to the formula for the hydrate. This dot does not mean multiply. It just simply tells you that these are chemically bonded together. It's called a hydrate, specifically dihydrate, because it has 2 waters within that compound, chemically bonded. Well, we want to know of this entire compound, what percent is the water? So to find the percent water, we need to consider the molar mass of water. Water has 2 H's and 1 O, and we know that that has a molar mass of 18.02 grams per mole. Well, in this compound, we have 2 moles of water, so we could take 18.02 and multiply that by 2. And you get the total amount of water in this compound, and that's 36.04 grams. That's our part. Now we need to find the whole. Well, we add those 2 molecules of water, that 36.04, to the molar mass of 1 calcium and 2 chlorines, and we get a total mass of 147.02 grams. That's the entire compound. So now we use the same percent composition formula of part over whole, and we see the part that's water, 36.04, divided by the whole of 147.02 grams. Don't forget, times 100, and you get a percentage of water of 24.51%. So use the mole anytime you need to do molar mass problems, and you will be getting great grades in your class. I guarantee it. Stay tuned for our next video over empirical and molecular mass. See you soon. This is awful.